Good morning, guys. We are approaching the end of the school year, so we only have a few more lessons left. Today I want to do a review. The question is, ants have 6 legs. How many legs would 6 ants have? So we have 6 ants. We're going to represent our ants by using circles. So we have 6 ants. 1, 2, 3, 4, 5, 6. We have 6 ants, and each ant has 6 legs. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, we can represent this drawing we just made by using an equation. We have 6 ants with 6 legs, which will give us 36 legs. That's just a visual way to show a multiplication problem. Now, I want everyone at this time to pause the video and make sure you have scrap paper, because you're going to need scrap paper for the rest of this lesson. So if you haven't had a chance, go ahead and pause the video, and then we're going to resume. All right, we have 4 rectangles. Try to draw them as close to the same size as possible. 4 rectangles. Now here's the question. There are 4 third grade classes at Sunny Elementary School. Each class is planting an equal part of a garden they share. Use the rectangles to show 4 different ways you could divide the garden into 4 equal parts. And think about when we talked about equal parts. When we talk about equal parts, that means all parts must be the same size. Let's first look at one way we could divide it. We could take these parts and we could divide them into fourths. We could divide another way into fourths. Another way for fourths could be or. Now notice, all of our parts are the same size. And since they're divided into 4, 4 would be our denominator and 1 would be our numerator. Each piece is worth 1/4. Now I want you to take the same paper that you were using, and this time I want you to draw those 4 rectangles again. But this time we are going to try and make some equivalent fractions. So we're going to use a different denominator for each fraction, but we want them to still be the same size. So my first fraction, we're going to divide into a half. 1/2, 1/2. So start thinking about another fraction we know that could be equivalent to 1/2. Well, we know that 1/2 is the same as 2/4. So if each piece is 1/4, 1/4, 1/4, 1/4, then I see here that my 2/4 is the same as 1/2. We can also find another equivalent fraction 1/2 by using 1, 2, 3, 4, 5, and let's do another one, 6. And this is going to be divided into 6. So 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and then 6, 6. And I know that 3, 6 right down the middle is also equivalent to a half. And our last piece we're going to divide into eighths. So 1, 2, 3, 4, 5, 6, 7, and then 8. So 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, and 1/8. And if you look at it right down the middle here, in the middle, we know that how many eighths do we need to equal a half? Well, we need 4/8. So we know that 4/8, 3/6, 1/2, and 2/4 are all considered to be equivalent fractions. Now we're going to look at some fractions on a number line. And once again, you're going to need your paper. So I want you guys to write down these fractions in the box. So we have 0 out of 8, 1 out of 8, 4 out of 8, 7 out of 8, and then 8 out of 8. And then we're going to create our number line, and we're going to place each of these fractions at their correct place on the number line. Well, we know that the first fraction, 0 out of 8, will be at the same place where we find 0. So we put 0 out of 8 there. We know that when we get to 1, we want to have the same numerator and denominator. Well, look at the fractions we have up top. Which fractions have the same numerator and denominator? The 8 out of 8. We just learned that 1/2 was equivalent to what fraction that's up there? What fraction did we just say 1/2 was equivalent to? 4/8. So we know 4/8 will be right there at the middle spot. We have a couple more fractions here. So we have 1/8. Where do you think 1/8 would go on this number line? 1/8 would go close to the 0. So 1/8 would here, and then finally our 7/8 would go closer to the whole. So that's how we put fractions on a number line. Now I'm going to show you guys a little bit more difficult way of looking at some fractions on a number line. And we're going to use some larger numbers. We're going to use something called an improper fraction. An improper fraction just means that the numerator is larger than the denominator. So once again, we're going to start with 0. This time we're going to go past 1. And then we're going to go to 2. I'm going to give you guys some fractions, and I want you to tell me where do you think each fraction goes. So we're going to have 2/8, 11/8, 5/8, 4/8, and 8/8. Now I want you guys to pause the video, and I want you to write down where each fraction should go. Now we learned earlier that the 2/8 should be close to the 0. So if 0 was here, the next fraction would be 1/8, which would be followed up shortly by the 2/8. Now 11/8. Where would 11/8 go? Well, we said earlier that whenever the numerator and denominator are the same, we have a whole. So if this is 8/8, 9/8 would go next, followed by 10/8, and then followed by 11/8. And of course, we learned earlier that 4/8 will be the midway section between the 0 and the 1. So our 4/8 will come right after 3/8. And now we're going to look at comparing some fractions using greater than, less than, or equal to. At our first fraction, we're going to use greater than, less than, or equal to. Now remember we said when we're looking at greater than, less than, or equal to, we said Pac-Man eats the larger piece. So we have 2/4, and we're going to be comparing it to 2/6. Now notice we have the same numerator. Remember when the numerators are the same, whichever denominator is smaller is the larger fraction. So 2/4 is the larger fraction, so Pac-Man is going to eat the 2/4. Let me give you guys another one. I want you to pause the video after I put it up. Let's look at 3/6 and 3/5. Which fraction is larger? Pause the video, use what you know about the numerators being the same. So we have 3/6 and 3/5. So our numerators are the same. Our denominators are different. This denominator is smaller, so this is the larger fraction. Pac-Man will eat the 3/5. We're going to apply that same theory, but this time we're going to change our denominators. And then that rule will change a little bit. So now we have 2/4 and we have 3/4. Well, the rule changes when the denominators are the same. When our denominators are the same, the fraction with the larger numerator is the larger fraction. So since 4 and 4 are our denominators in this fraction, and since 3 is the larger numerator, 3/4 is larger than 2/4. Let's look at one more. We have 5/6, and then we have 4/6. Using what we just learned about the same denominator, pause the video, tell me which fraction is larger. Since the denominators are the same, the fraction with the larger numerator is the larger fraction. So 5/6 is larger than 4/6. For today's lesson, when you guys go to Classroom, I have some questions inside of Classroom. I want you to answer the questions using the information from the video. Be safe, guys.